so this is going to be session 2. This has your calculator. For whatever reason, it won't let me use the actual system. So we're just going to rock it this way today. If you need to learn how to use the system, I did 3 other videos inside the system. So here's the first one here. You have the system here. We're going to take this system, we're going to put it in Desmos. So I take this system here. Let me split screen this so that way I don't have to hop back and forth. Yeah, that way I don't have to hop back and forth. All right, so here we have 2x plus 2y equals 17, and then we have 4x minus y equals 25. You want the x value. There's your x value of 6.7. Okay, x value of 6.7. Trying to make that bigger. Doesn't really want to go bigger, does it? There you go, 6.7. All right, let's go to my next one. My next one is here. Here's a quadratic function. All right, it doesn't give us the actual quadratic function. It just shows us that, hey, this is a quadratic. Which quadrant would the vertex of x plus 3, x plus 2? All right, so there's 2 ways of doing this. Actually, there's 2 ways of doing this. First of all, there's knowing the actual way, right? Knowing that with this in your vertex, knowing that a change in x, right? A change in x plus goes to the left, and negative goes to the right. Change in y, right? A change in y, plus goes up, and a negative goes down. So if you understand the math facts, what the math facts are saying with this is that a change in x, I'm going plus, which means to the left 3, and then I'm going plus 2, that's your y, which is up 2. So I'll go from here, going 1, 2, right? And then 1, 2, 3. So that would be here, which is in the second quadrant, meaning the second quadrant is your answer. Now, let's say that you don't know that. All right, let's say that you have no clue how to do any of this. Mr. Lemons, what is a great way for us to be able to do this? Mr. Lemons, what is a way for us to use Desmos? Okay, so there's probably a better way to do this. I thought I chose the better way. For some reason, it's just not doing it for me. All right, we're not having a good community today. All right, so all right, so here we go. We have a great way to do this is just use a random quadratic. So x squared plus 3x plus 2. That's a very basic quadratic, okay? Let's see what happens to it. So we have x. Let me move this up out of the way. We have x squared plus 3x plus 2. All right, so there's my quadratic there. So there you go. It sort of kind of looks like the one that we have, but not really. But here's the big thing about it. What we need to do now is this is f of x, right? This was f of x equals this. So now f of x equals x plus 3 plus 2. So what that means is that I'm going to say everywhere I have an x, I now have an x plus 3. So x plus 3 squared plus 3x plus 3. And then I have a plus 2 and then another plus 2. All right. I'm just going to put all that into Desmos. All right, you don't have to actually do the math. You just got to be able to put it in Desmos. Plus 3 parentheses x plus 3 close parentheses, and that would be plus 2 is 4. So there you go. So what happens to my vertex? Here to here. If you notice with it, what does it do? It goes up 2. Okay, it goes up plus 2, and then plus 2. All right, what happens to my vertex? Okay, I think I was actually supposed to add another plus 2 here. Let's see if that's right. Add another plus 2. Is that right? Yeah. All right. So, what do you? All right. So it goes up. What you notice again is that it goes up and then it goes to the left. Okay. It goes up and then it goes to the left. Okay, it's not an exact science. It doesn't go up exactly 2. All right, but you'll see that it goes up. Anytime that this is going up, and you know it's going to be in a quadrant, it's going to go up into the other quadrant if that's the question. It's going to go up and then to the left. Okay, so it's not an absolute perfect science. All right, on how to get it correct, but it gives you an indication of what is the graph doing from the original to the next. Okay. So that is more of a desperation move versus an actual, hey, that's what I want you to do. Okay. All right, let's move on to the next one. The next one is just solving for L. So we have P equals 2L plus 2W. I'm going to subtract the 2W from both sides. That gives me P minus 2W equals 2L. Divide the 2, and that cancels, and P minus 2W over 2 equals L, which is, which one? B? So B would be your answer there. All right, number 18. Number 18, it says we have a projectile shot in the air. Time is t, right? Time is t. Altitude is ht. All right. Which of these measures true? The maximum is 12 feet. So let's go to 12 feet. 12 feet, give or take, is about right there. All right. Is that the maximum that it goes? No, it goes above that, right? So it's not A. The projectile reaches its maximum altitude after 12 seconds. Well, where is its maximum altitude? Its maximum altitude is, I know I'm going through 20, but it tells us it's not 20. It tells us it's actually 19.4, right? This is actually 19.4, which means 12 is the seconds. That's the maximum. So 12 seconds after flight, yes, that's the correct answer. The projectile is launched from the ground. Look, this is the ground, right? That's the ground. 0, altitude. 0 is the ground. That's the ground. It's launched from, it has a starting point of 5 feet above the ground. So this is not true. The altitude of the projectile increases from 5 to 20. All right, from 5 to 12, it goes up, but from 12 to 20, it goes down. So that's not true. So D, all right, so B is the only one that can be the answer. All right, part B. Part B is looking for the, take the table, which statements is true. Okay, so this is saying H of 4, right? And this says HT, so the T goes in the parentheses. So H of 4, so that would be T is 4, is 13. 13 is greater than H of 20, so go to 20, that's 13. Is that a true statement? No, those are equal, so that's not true. The flight is symmetric about t equals 10. So t equals 10 will be right here, which means that the numbers on one side of ht are the same as the numbers on the other. Is that true? No, you have 17.8, then 19.4. Okay, 12 is the symmetric. 12 is where it's symmetric. So that's not true. The projectile will hit the ground at some value less than 24. We'll take a look at 24. Has it hit the ground yet? No, it's still 5 feet above the ground. Okay, so that means over here at some value greater than 24, it's when it's going to hit the ground. So that's not the answer. D is the only one it can be. Even though you don't understand what this means, D is the only one that it can. And all this is saying is that basically this is that 12 is the line of symmetry. 12 is the line of symmetry. They're just saying that using math, which this is, of course, true. 12 is the line of symmetry. All right. A random sample of 20 teenagers participated in a test based on the information given. Which statements are true? All right, select all that apply. All right, 40% of the participants were girls, so let's go to total. Total, I have 80 girls out of 200. 80 out of 200 is 40 out of 100, which is 40%. That's true. That's an answer. 70% of the participants preferred A. All right, so this is 70 people out of the boys and girls out of the 200. So this is 70 people, not percentage. Not percentage. So this is false. 20 out of 120 boys preferred D. So that is D right here. D, the boys. 20 boys out of the 120 boys preferred D. That's true. So that's an answer. 10 out of 35 participants preferred B were girls. So here we go here. B, of the 35 that chose B, 10 of them were girls. So that's true. Right? So that's an answer. Proportion of boys who preferred C is equal to the proportion of girls who preferred C. All right, so we have 30 and 30, boys and girls, right? So it says 30 over equals 30 over. Now let's get our totals. 120 and 80. Is that true? No. All right, let's go to number 20. A local theater sells admission. Going through reading. There's my function. What is the domain? What's the domain? Remember, domain is the x values. Domain is x values. All right, so we're talking about customers, right? We're talking about people. All right, so what do we know about people? You can't have half of people. All right, you can't have a half of a person. You can't have 0 people. Nobody can show up. If it's in a building, you can't have a crazy amount show up, right? That's not possible. You can't fit 1 million people in one spot, right? There's no stadium large enough in the world to fit 1 million people in one spot, okay? So this is a movie theater, right? A local movie theater. This isn't like the world's largest movie theater. So just think realistic. All whole numbers. Well, all whole numbers. Can 1 million people, because 1 million is a whole number, right? Can 1 million people go in that movie theater? No, right? All negative rational numbers. Well, rational means negative. So can a half a person? Do we have half a person? No, can't have half a person. All negative integers, all non-negative integers that are multiples of 8. Well, can 8 people can 8 people show up? Can you go to a movie and only 8 people be there? Yes, you can. And that's not a multiple of 9, right? So that's not true. And so D is the only one that is the answer. All non-negative integers that is less than or equal to 100. So that means 0 to 100 people, which is true because that's what it says here. It holds 100 customers. All right, so that one's a true answer. All right, so here's the graph, y'all. This is easy peasy whenever you get one like this, okay? It just wants to know, hey, what is X? X is where it comes together. Where does it come together? You can put this in Desmos. You can put this in Desmos, and it gives you the answer. But what is the X value when it comes together? -2. -2, move on. All right. Here's one you put in Desmos. Put this in Desmos. So we'll say negative 3x plus 6y plus 5 uh, equals negative 7. So it gives us our line. Then you hit the next line. Then you're going to hit the plus button and click table. That way you get a table and you can enter in your values and it gives it to you as a table. And all you're doing is seeing, hey, which one's on the line. All you're doing is saying, hey, which one of these will be on that line. Select all that apply. That means it's only going to be 2 or 3. All right, select all that apply. So it's probably only going to be 2 or 3. And as you can see, it is those two there. It is this one and this one. All right, so we have number 23 at the beginning of an experiment. At the beginning of the experiment, bacteria colonies where time is 0. We have time is 0. The bacteria, the average rate of change. Oh, so you're going to have to take the average of the rate of change. Okay, for the first 5 minutes of the experiment. Okay, so if this is my equation here, so let's say that, well, t is going to be, it says t starts with what? 0? So if t is 0, and that would be bt, it says bt equals 4 times t, 2 to the t power. So that would be 4 times 2 to the 0 power, which is 4 times 1, which is just 4. All right, and then let's do number 1. Number 1 is going to be 4 times 2 to the first power, which is just 4 times 2, which is 8. All right, I'm going to do one more. It looks like it's doubling every time. So I have 4, 2 to the second power equals 4. 2 to the second power is 4, which is 16. Yeah, it's just doubling every time. So that means 3 is going to be 32. 4, I know I'm getting toward the bottom of the page, is going to be 64. And then I'll just write it here. 5 is going to be 128. All right, so now I have to take the average, right? These are my rates of change. Okay, so now I have to figure out the rate of change. Now I got to figure out the rate of change, okay? So from 4 to 8 is 4. From 8 to 16 is 8. 16 to 32 is 16. 32 to 64 is 32. 64 to 120 is 64. So there are my rate of changes. So I have to find the average of those rate of changes. So what I'm going to do is you can just use the regular calculator if you want to, or you can still use Desmos. Plus 8 plus 16 plus 32 plus 64, not there. All right, so that gives me 1, 2, 4. Whenever I add all these up, whenever I add them, I'm going to take the average. So there's 5 of them. And I will take 124 and divide that by 5, and I get 24.8. 24.8, which is my answer here. 24.8. Then it wants the units. The average rate of change is the number of bacteria for the first 5 minutes, right? So it's bacteria per minute. So it's this one. All right, let's go to number 24. Number 24, combine the estimates of Atasha National Park. Northwestern elephant population can be predicted. So here's the equation. B is the number of years since 1995. What does 2649 represent? 2649? Nope, it's not there. Okay, so it's going to represent a number that's not on this table. All right, let's see. Predicts the increase of number of elephants each year. it does not increase by 2,000, right? It does not increase by 2,000. Please tell me you see that. It does not increase by 2,000, right? So this right here actually represents the number that it increases, right? The 1.045. That's the percentage. So it's not A. The number of elephants in the region from in 1995. All right, so this is year 3, right? So we see we can get a rate of change here. This is a rate of change of 2, rate of change of 2, rate of change of 2. So we can go back, right? If this looks like 410 is what this looks like, right? And I mean, this is an estimate of 410. So I mean, of roughly 410. It's not going to be that way every time. So I mean, because it's just an estimated rate of change, but still. So if I go back 400, right? If I go back another to 96, right? And I drop 400, that should be 2,800. And then I go one more year, half that, right? Half of that from the years previous. So that'd be roughly about 2,600. So 2,600, yeah, that's my answer. When the year is predicted to stop increasing, well, it's hopefully the goal of this is for them to not be predicted to stop, right? So that's the goal of this, is to track it so that way it doesn't stop increasing. The percentage of the elephant population is predicted to percent each year. That's not a percentage, right? Because if that's not a percentage, the percentage again looks something like a 1 point, because remember 100% is 1.00, right? So it wouldn't be that either. So B is the only one that it is. If you knew this, you knew that your formula here, right, is that A, B, and then T, whatever value of T that it may be. You know that A is your starting value. Okay? You know A is your starting value, so that would be. All right, let's move down. Use quadratic equation. Man, look, I already know I'm going to have to put that in Desmos. Look, so I'm going to go ahead and just put that in before I read anything else. Let me just go ahead, knock that into Desmos, so that way I got something to look at while I read it, so that way I can kind of see what they're talking about. Okay. Can be rewritten as the equation of negative 2x plus what, parentheses 2 plus what. Therefore, the vertex of the graph is this. Oh, well, at least we already done that. We got the vertex. The vertex is right there, 1, 7. Desmos, right? 1, 7. We got that one. All right, so what they're asking you to do is this. They're asking you to put this into vertex form. They're asking you to put this in vertex form, which is ax minus h squared plus y equals 0. Okay? They're asking you to put this in vertex form. With your vertex, right, h and k are your vertexes. All right? H and K are your vertexes. All right. And so if I would put these in, I would get, if I would put these items in, I would actually get, because again, this is a positive one that I'm putting in, right? And so this would be AX minus, which is a positive one, squared plus 7, all right, which would make this x minus 1 squared plus 7, all right? But up here, this is why you get it wrong. It has that little symbol there, which means it says that it's positive. So what is the positive version of negative 1? If I have to say x plus, then I say x plus a negative 1 instead of saying subtraction, right? Plus 7. So this is actually a negative 1 and a 7. You can graph that in Desmos to make sure that your answer here looks like your answer here. Okay, if you put it as a positive one, it will not work, right? It's going to actually be inverted. Well, it won't be inverted, but it won't work, okay? It'll have the x value at -1. It'll put the x value actually here and graph it from that point, all right? So you need to make sure that if you check in your answers, put it in Desmos, check your answers, all right? This here must match this. They have to match in Desmos. Okay, if they don't match, you did something wrong. You got the wrong answer. Okay, all right. Satisfies the definition of a function. Ooh, function, function, function. Right? We like functions. Functions are one input, one output, which means one value of x can only give you one value of y. Which one satisfies the empty cell as a definition of a function? Ooh, check that out. All right, so any numbers that repeat cannot be an answer. All right, 5, and look at your inputs, does it repeat? That's an answer. -1, oh, that repeats. That's not an answer. 0, oh, that repeats. Nope. 2, nope, 2 doesn't repeat, so that's an answer. 11, up, that repeats. That's not an answer. 17, up, right there at the very end, and that doesn't repeat, and there are your two answers. All right, so moving on to Phil and Matt made cookies for a fundraiser. Phil and Matt made 25% more cookies than Matt. The cookies sold at 25 cents each. After the sale, 20% of the combined total of their cookies remained. Create an equation to represent the total amount of money that they earned. Put the equation in the box. Okay? Put the equation in the box. All right, so we're going to define our variable. So we're going to say that m equals cookies Matt made. We're going to say m is the cookies that Matt made. If that's the case, then if that was the case, then we would have 1.25 m. That is the cookies that Phil made. Right, that would be the cookies that Phil made. Being that Phil made 25% more, he made the same amount. That's 100% plus 25 more percent more. Okay, so they sold what at a quarter a piece. All right, so they sold them at a quarter a piece. All right, how many of them did they sell? They only sold 80%, right? They only sold 80% of the cookies that they have. So let's say that, let's say M, or no, we already used M, right? Let's say that, what's a good letter for money's total money that they earned, total amount? Let's just say capital A, right? A for total amount of money earned. Okay, so let's put this all together. So A equals capital A. Sorry, equals. They sold it for a quarter apiece. They only sold 80%. 80% as a decimal is 0.8. They only sold 80% of their cookies, right? And then how many were made? Well, you had Matt made M cookies, and then Phil made 1.25 of the cookies or whatever that were there. So that would be our equation. It says enter your equation. Well, there's our equation. And explain your cookie. Explain your equation. All right, so I have to explain my equation. All right, so basically this is that uh, you take each cookie cost a quarter, and they sold 80%, which is 0.80. What did I do to those? I multiplied them, so that's what I'm just going to say. Multiply uh, 0.25 times, run out of space over here. All right, I'll just do a new line. Multiply 0.25 times 0.8. Of the total amount Matt and Phil made. Total amount of cookies. Total amount of cookies Matt and Phil made. All right. Each cookie cost a quarter, and they sold 80%, which is that. So I'm gonna multiply of the cookies. All right. So the cookies are whatever that they made. So that's my explanation. So part B. Part B. Now it's giving us some figures, right? They made $72. All right, they made $72. How many cookies did Phil make? How many cookies did Matt make? Show your work. Okay, so we have total equals 72, right? And what was our equation? You may have to flip back to make sure you get your right equation. Our equation was A equals 0.25 uh, times 0.8 times m plus 1.25 m. All right, so now we know what our total is. So our total is 72, and that equals parentheses. All right, so we have that there. Let's see. If I would go ahead and add m plus that, that would actually be a 2.25 m. If I went on and add those, that just kind of simplified my things there. All right. Let's see. Let me go ahead and I will multiply the 0.25 times 0.8, and there you go. There, simplifying stuff even more. So that is 72 equals 0.2 of 2.25 m. So 2.25 m, that would be uh, times 2.25. That is 72 equals 0.45 m. Oh, it's shrinking. I don't like that it's shrinking. I don't want it to shrink sizes. Let me zoom that out there. I don't like that it's shrinking. There you go. All right. And so that would be, let me make sure this knows it has plenty of room to operate. There you go. And so that would be, then you would divide, right? So then I would say 72 divided by 0.45, and that would be 160, right? So that gives me 160 equals M, and we know M is the number that Matt made, right? And so Matt equals M, and so that means that 100 and Matt made 160 cookies. All right. And so now we got to do Phil. Phil, right? What did Phil equal? He was 1.25 of Matt's, which is 1.25 of 160. And what does that equal? We have 1.25 times 160, and that is 200. So 200. So Phil made 200 cookies. All right, there you go on that one. That's how you do that one. All right, let's go to part C. Next year, they may sell the cookies at 50 cents. They plan to make the same amount of cookies, but they predict they will only sell 70% of the given prices. Based on their prediction, should Phil and Matt raise the prices? Justify your answer. All right, so we're looking back up here. All right, looking back up here, here's what I'm going to do. I'm going to take this, okay, and I'm going to I'm going to take my equation, all right, and I know I need to move my equation. You're just going to have to retype it for the sake of time. I'm using the the computer options, being able to copy and paste it. I don't know if you have that as an option on your test, but you're going to have to rewrite that equation, right? Rewrite it so that way this is the original. That way you know it's the original. And so now it's going to be A equals 50 cents. They're only going to sell 70%, so that's 70%. And they're going to make the same number of cookies. Well, we know the number of cookies now, 160 plus 200, right? We know the number of cookies. All right, so now I'm just going to put all this into Desmos, and I'm going to say 0.5 times 0.7 times parentheses 160 plus 200. Let's put that all in Desmos, and they're going to make $126. All right, they're going to make $126. So, should they do this? Yes. Why should they do this? Because they made $72 the year before. That's what we got, right? So they made $72 the year before and would make what is that? 126 minus 72. 126 minus 72. Over $50, right? So they would make over $50 more if they raise the prices. They raise the prices and sell 70% of the cookies made. All right. So if they're going to make more money, all right, and you're selling stuff and the goal is to make more money, and you're going to make more money if that's what you do, right? If you're going to make more money, the goal is to make more money. All right. If the goal is to make more money and you're able to make more money, then yes, they should raise the price to 50 cents. Okay. That is how you do that. Let's see what else we got. Go on to the next page. All right, we got the last question here. It says, consider use the information provided in part A through C for question 28. Consider 3 points. Use the information provided to answer part A through C. Consider 3 points. Graph the line that passes through these 3 points on the coordinate plane. Now, the thing about this is that you have this here, but you have Desmos, right? And so what you do is you go into Desmos and you enter in these 3, so that way you get some local stuff. Go here, table. All right, and I'm going to say -4, and then we'll go here to -3, and then I'm going to say 20 and then 15. And you're like, Mr. Lemons, it's not popping up. Just wait 1 second. I'll show you exactly how to do it. All right, make sure you pay attention. I want you to left click and hold right there. Okay, click line, and boom, turns it into a line. Okay, you click, you turn it into a line. All right. You click, you turn it into a line, all right, and there you can get some points. So not only on this line right here, right, we can click right on that line, we get good points. We see that 0, 0 is a good point, okay, so that passes through. So if I were to graph this line, right, your tools are going to be far better than my tools that I have here that I'm working with. All right, your tools will be far better. Inserting a line, you're going to do a line that goes through 4, -3, which is there, and something that goes through All right, so your line is going to look something like that. You'll have better, because you see here 0, 0 is a spot. What is that? 4, 3 is a spot. And so you're able to go. If you don't know if those things, if you're like, hey, is 0, 0 actually on there? I'm going to enter it in. All right, so I'll enter it in here. Let's go here and say, well, is 0, 0, right? Is that on the line, 0, 0? And you see that red line runs through 0, 0. So yes, it's on there, okay? All right. So your stuff will be far better than mine as far as your tools. You'll be able just to click on points and then make lines. You'll be able to do it a lot easier. All right, so it says use the graph part A, explain why the ratio of the y coordinate to the x coordinate is the same. Okay, so this is just getting into this is really just getting into making sure that you have a firm understanding. Okay, is that basically this? Why is the ratio the same? It's a proportional ratio. This is a 7th grade concept. It's a proportional ratio. It is a proportional ratio because it passes through the origin. Okay, it is a proportional relationship because it passes through the origin. Okay, because it passes through the origin. It says except for it has the same except for the y-intercept. Okay, the y-intercept is not the same, right? It's a proportional relationship because it passes through the origin, right? And so because it's proportional, right? It has because it has a slope that is constant, right? Slopes are constant. I'll just make a new line, right? Uh, the slope of a line is constant. A slope of a line is constant, right? The slope of the line is constant, meaning that the ratio will stay the same, except for the y-intercept, right? Except for the y-intercept, which is 0, 0 over 0, right, which would be divided by 0, right? It would be divided by 0, which is undefined. Okay, so there's that one. All right, let's see, part C. Do the points on the line have a constant ratio? All right, so basically is it the same? All right, so is it roughly, does it have the same? I can already tell you no. Why do we know it's not? Because we learned again in 7th grade, 8th grade that in order for something to have a proportional ratio, it cannot have a constant at the end. Y equals 3x, right? That would be proportional, right? But because it has a y-intercept of that -2, it's not, okay? So, I mean, you can already look at it and see that the equation y equals 3x minus 2, it has a y. Let me go ahead and just zoom this out too. It has a y intercept of -2, so the line will not pass through the origin. It's not going to go through the origin, so it's not proportional. Okay, and so the line will not have the same properties as the line in part what B? Line in part B. And there you go. There's that. And stop. So that means that is the end of session 2. Good luck, everybody.